Okay, in this assignment, you're going to set it up like this. We've done this before, segment bisector, which is a perpendicular bisector, I should say, but that's okay. Segment bisector using circles, your name, date, class period, and this is the long edge of the paper. This is the 11-inch side, so make sure it's in landscape mode or it's horizontal, same thing, just not vertical. And draw a line that is about, 3.5 inches. Don't do much bigger than that. Like you can do 3.5 inches, but if you do 3.5, your measurements will be the same as mine when it comes out, okay? Label it A and B, and then set your compass to something a little more than half. So I don't know what that is. I'm going to, you know what, just for kicks, let's measure it at maybe 2.5 inches. Well, what is that? If I do that, that's 2 inches. Let's go 2, well, can we do 2.5? My compass tends to get wonky if I make it too big, so right there, that's about 2.5 inches, okay? And will the circles fit? You know what, that may be too big. I'm gonna take it down to about 2. Because I don't want it to creep into the writing we have. So I do want to show you the concept behind this, why perpendicular bisector works with circles, but normally we would make an arc out here and an arc down below. Well, we're going to make the whole circle, okay? So make a whole circle around B with B at the center. And then a circle with A at the center. And I think I have more luck if I just rotate my paper around, so I'm going to do that. Nice, neat little trick. Okay. So there's A and B at the center. Now, we've done perpendicular bisectors before, and we've usually just made this mark and that mark and this mark, the little X's. But I want you to see what's going on with these circles. When you know a circle is the set of all points that are equidistant from another point, every point on this line is the same distance away. Draw another line, draw your perpendicular bisector, a little bit sticking out, a little bit sticking out there. Mark that this is perpendicular. And let's see what's going on. So this half from A to the center is exactly the same as B to the center. And if we want, we can measure it. So here, that's like at 1 3/4 inches. And if I measure here, this is at 1 3/4 inches. So now, this point right here, how far is it from here to here? Well, if I measure, actually I'm going to draw the line. I want you to actually draw a dotted line. We're going to connect all of these, okay? So a dotted line right there. But before we do the others, I want to measure it. This should be the radius of our circle, 2 inches. Remember we set our circle to be 2 inches? And it's 2 inches from A to here, but not here to the center because we overlapped a little bit. Anyway, so go ahead and draw your dotted line from here to here, A to this other intersection. And I think we need to label these, so I'm not just saying here and here. So let's label this. This will be X, and that's going to get run into, and this is going to be Y. And then do another dotted line to B, and we'll take a look at what we've got. And if you need to, pause the video, do what I'm doing. Maybe if you have to start over, that's totally fine. All right, so what we've got, we have this here, we measured at 2 inches, right? So if that's 2 inches, what will all these others be? Well, this is a radius, so if this is 2 inches, then this is also 2 inches, and this is also 2 inches, and this is 2 inches. They're all 2 inches because they are all radius from identical circles. But they're not the same as here to here. We just created a triangle with it's a right triangle in fact. And in my case, this is like less than an inch. It might be like, that's 3/4, that's 7/8. This looks like 15/16. Anyway, we don't need to write that. But this is called a rhombus. It is like a square. A square has equal sides, but it also has 90-degree angles. Now, if I were to measure an angle here, let's do our best at trying to measure an angle here. I'm going to measure this angle from here to there. And if I measure this angle, I put that spot right there and I rotate this black line till it's right on top of that dotted line. Make sure I can see the vertex in the hole, and I imagine where that line would continue. Here's 10 degrees, 20, 30, 40, 50. Here's the 55, and there's the 60. This is about, and I'm measuring both angles. This is about a 57, 58. So if the whole thing here is 57 degrees, this one also is 57 degrees. What would these be? Well, all the angles in a four-sided figure add up to 360. Or if we half that, we can half the 57, which is going to be, what, 23 and a half, no, 28 and a half? 28, yeah, 28.5 right here. And this is 90. What would that other one be? 28, let's see, 90 minus 28.5 should be 118.5. No, I'm getting that wrong. Wrong math. If I take, oh, yeah, I know why. Because this is 57, 57, 57 doubled is 114. 360 minus 114, 360 minus 114 is, oh my gosh, I can't even subtract. Clear, 360 minus 114, 246, divide that by 2. That means this should be 123 right here. 123 degrees, and this should be 123 degrees. So this angle here is the same as this angle here, which is 123. This angle here is the same as that one. Anyway, so it is not a square. It is a four-sided figure with equal sides, but a square would have to have 90 degrees here and 90 degrees there. These two angles must add up to 180. But anyway, that's the assignment. Make sure it is as neat as you can get, and turn that in.